13 on the homework, let's start this out. What's step one to any of this stuff? What's the most important thing when you graph a parabola? The vertex. So let's do that. The vertex will be a coordinate, and you find that by going x equals negative b over 2 times a. Not only that, you usually replace your b and your a with parentheses. And keep in mind, the standard form equation is ax squared plus bx plus c. Now, what is your b value? It's 0 because there is no b value. There is no x term. It is kind of weird that the square came out kind of funky, kind of high up here, but that's how it printed out. I'm sorry. But anyways, yeah, there is no b value, right? If you really wanted to, you could put a plus 0x and plus 0, so you could clearly see that your b value is 0 and your c value is 0. But, I mean, it's really not necessary. You could see that there is no b, so put a 0. What's the a value? It's negative 2. So it doesn't really matter because negative 0 is still 0, and divided by any number is still going to be 0, correct? So our vertex x value is 0. We want the y value of the vertex. How do you find that? Yeah, you simply plug it in. Take in your x value, plug it in right there. 0 squared times negative 2. What's your answer going to be? 0, 0. That's right. So your vertex 0, 0. Okay. And let's start a sketch here. So we're going to put a dot at 0, 0. Now, where's my axis of symmetry? So, what is our axis of symmetry? Remember, it's simply the equation x equals the x value of your vertex, which in this case is 0. So there's another point that you're going to get on tomorrow's test. You get 1 point for the vertex, 1 point for stating the axis of symmetry. We get another point for actually graphing it. So you could draw your axis of symmetry right through that vertex. You don't have to, because it's clear that the y-axis is the axis of symmetry. Let's get some more coordinates. How do you get more coordinates? XY table. Okay, so let's do a quick XY table over here. And remember, it's a good idea to plug in two values that are on the same side of the axis of symmetry. So what two numbers would you like to plug in? 1 and 2. Okay, so when we plug in 1, and we can do this in our heads, I'm going to take this 1 and plug it in right into the x. What's 1 squared? 1. And what's 1 times negative 2? There you go. So that's the coordinate 1, negative 2. So if we go to 1 on the x and negative 2 on the y, I'll end up right there. Yay? I want to map it over to the other side so it'd be right there. And remember, this is a sketch. So far we have this parabola. That's pretty good. Let's plug in 2 now. Again, it's just a sketch. So plug in 2 right in here. 2 squared is what? 2 squared is 4. And 4 times negative 2? Negative 8. Now, we already know that that coordinate is going to be... I don't have to move this whole thing up. Whoa, what is happening? We're going to have to move this whole... What? To graph the coordinate 2, negative 8, you're going to have to move way over here to go 1, 2, and then negative 8 way down here. So again, it's just a sketch. I'm just going to put my dot way down there. I want to map it over way down here. So if, like on tomorrow's test, if I give you a 5 by 5 graph, the negative 8 is going to be off the graph, so it's not even necessary to draw that. But in this case, it's a sketch. You could draw it down, or you could just put an arrow right there and just erase this part. Whatever. It's all good. So it's a sketch. You get 2 points for that, for graphing it. Now, if I do give you a graph paper, or a graph on that section, you do have to make it accurate at the right coordinates and stuff. Anyways, what else could I ask you on tomorrow's test? I could ask you for the domain and range. Let's talk domain. We're going to say x equals all real numbers. You can't just say all real numbers. You got to specifically say x equals all real numbers, because you're talking about the x values, and it really does go left and right forever. Let's talk about the range now. The range is talking about your y values, right? So y is what? Less than or equal to 0. Excellent. So that's another point right there, or maybe even 2 points right there for the domain and range. What else could we ask? We could ask for Is it a max value or a min value? So it's definitely a max. And now what is the max value? You could say y equals 0. Technically, you could give me the value of the vertex. You could say that the max value is 0, 0. But when you're talking about max or min, you're talking about y values. So the highest y value is 0, so you could say y equals 0. So this would be another point right there, stating that it's a max value, and that max value is y equals 0. Okay? I could also ask you, somebody said, what was that? Y-intercept value. That's right. So the Y-intercept value, the Y-int, that's simply going to be your C value. So if we go back to the original and look at the C value, what's the C value at the very end? It's 0. Yeah, so the Y-intercept would be 0, 0. Or the Y-intercept would be 0. No. You could just put 0. You could give me the coordinate. Either one's good. I'll accept either one. Let's try number 15, guys. Number 15. Okay, so I want to start again with the vertex. The vertex is a coordinate. How do I find that coordinate? X equals negative b over 2 times a. I'm not even going to write it down anymore. I'm just going to write it with the parentheses already set up to plug in values. What is my b value? No. The b value? 0. There is no b, right? And so it's going to be 0, right? Remember, it's always ax squared. There is an x squared. That means your a value is 1. Bx, there is no x, so 0x. And the c value is always a number at the end. So when you plug in 0 for b and your a value is 1, it doesn't matter because you're going to get 0 divided by 2. It's still going to be 0, right? So your vertex x value is 0. So right off the bat, you could say, okay, well, if my vertex x value is 0, my axis of symmetry, what's that going to be? Don't say 0. Say x equals 0. Remember, you need the equation x equals 0. If you just say 0, you're giving me a number, and that's not the right description of the axis of symmetry. The axis of symmetry is a vertical line, and vertical lines are the equation x equals a number. Okay, so we still need the y value of the vertex. How do I find the y value if I already have the x? Plug it in. What's 0 squared?
0.
What's 0 plus 3? Okay, so the vertex is 0, 3. Let's start sketching this guy. All right, so we have a graph. What's my vertex? 0, 3. Let me go 0 on the x, 1, 2, 3 on the y. It's going to be somewhere down here. There's my vertex. And it's not there. It's at 3. Thanks. Let me change that. 1, 2, 3. So that's a dot up there at 3. Thank you. I would have messed up on that. Okay, so we have the vertex. We have the axis of symmetry. How do we graph this guy? You need coordinates, right? You need more coordinates. What do? XY table. So a lot of us jump to an XY table and plug in some numbers like 1, 2, and 3. But check this out. My a value is what? It's 1. Now, the option, if your a value is 1 or negative 1, you could use the pattern. And now these aren't coordinates. This is a pattern. 1, 1, 2, 4, 3, 9. Okay, so this is just like a shortcut. From the vertex, you know that it's positive 1, the a value, so you know it has to open up. If it were negative 1, it'd be opening down. So if you know it's opening up and you could use the pattern 1, 1, 2, 4, 3, 9 from the vertex, that means that you could go 1 over 1 up and put a dot right there. You could go 2 over and 4 up and put a dot right there. You could go 3 over and 9 up and put a dot way up there. So I'm just going to use a couple of points. If I go 1 over and 1 up, I'm right there. If I go 2 over and 4 up, I'm up there. And if I map it over to the other side, I'll be right there and over here. Does that make sense to everybody? Let me just connect my dots here, and I have my perfect parabola without doing any math. I just used the pattern. Now let's say you did want to use an XY table. That's totally fine. It's up to you whether you want to use an XY table or if you want to use the pattern when your a value is 1. So if you did want to plug in 1, go for it. Plug in 1. 1 squared is 1. 1 plus 3 is 4. That's right, 4. Now let's plug in 2, right? Plug in 2. 2 squared is 4. 4 plus 3 is 7, right? Plug in 3. That's going to be 9. 9 plus 3 is 12. It's already off the graph. So if I did go to these two coordinates, 1, 4, okay, 1 on the x, 4 on the y, I'd get to right there. If I did go to 2, 7, I'd go 2 on the x, 7, I'd be up here, right? So I'd get the same points, I'd get the same mapping over, and I would get the same parabola. Does that make sense? So you could use the XY table, or you could use the pattern. That's totally up to you. What else could we say? The domain is what? X equals all real numbers. It's important to write x equals, and the range? Y is greater than or equal to 3. So you're at 3, it's all above 3. It does actually touch 3. The vertex is 0, 3, so it is included. You have to have the or equal to. What else? You have your Y-intercept, which you could already clearly see is 0, or you could look at this, is 3. The C value is 3, so the Y-intercept is 0, 3, or you could just say 3. So the Y-intercept is 3. What else could we say? Max or min? That's a min value. Okay, so let me write min. And what is the actual minimum value? Y equals 3. There you go. And that's, we're stating a lot of things, and we sketched the graph. So think about all these points that come from this one quadratic standard form function. You have a point for vertex. You have a point for the axis symmetry. You might have 2 points for domain and range. You get another 2 points for graphing. There's a lot of points coming from each of these.